Hello everyone, I am Dr. P. Pramod Kumar, Associate Professor of Department of Mechanical Engineering, MLR Institute of Technology. Welcome to the course on Engineering Mechanics. Today we will discuss the basics of Engineering Mechanics course. The overview of my presentation is Introduction to the Mechanics, Force and its Characteristics, System of Forces. Let us start. Introduction to Mechanics. Engineering Mechanics is the branch of physics which studies the force and its effects on a rigid body. Engineering Mechanics is the branch of physics which studies the force and its effects on rigid body. A rigid body is the body in which the deformations are negligible or neglected. There is no rigid body in the universe. It is an imaginary body which is used for finding the force transmission. Engineering mechanics is divided into two different branches. One is statics and dynamics. The dynamics in turn classified into kinematics and kinetics. Statics is the branch of engineering mechanics which deals with only motion, which deals with force and its effects on the body which are at rest. And dynamics is the branch of mechanics which deals with force and effects on the rigid body which is under motion. Statics is the branch of mechanics which deals with force and its effects on the body which is at rest. And dynamics is the branch of mechanics which deals with force and effects on the body which is under motion. The dynamics again classified into two sciences. One is kinematics. The kinematics is the branch of dynamics which deals with which studies only motion of the body, not the forces causing the motion. The kinematics deals with only motion, not the forces causing the motion. Whereas kinetics is the branch of dynamics which studies both motion as well as forces causing the motion. This is the classification of engineering mechanics. Let us now start statics. Let us start with the definition of force. Force is any action which will change the state of the body. Force is any action which will change the state of the body. The state here is rest or motion. If a body is under rest, to change the state of the body from rest to motion, we need to apply force. Similarly, if the body is under motion, to bring it back to rest, we need to apply force. So therefore, force is defined as any action which will change the state of the body. Let us see the characteristics of a force. The characteristics of a force are magnitude, direction, point of application, and nature of force. To define a force completely, we need all the four characteristics. If any one of the characteristics is missing, the force is incomplete. Consider this example. A body is acted upon by a force 10 newtons at 30 degrees to the horizontal. Now let us see what is magnitude here. How much force is acting on the body? 10 newtons. 10 newtons is the magnitude of the force. Direction. The force is acting at an angle of 30 degrees to the horizontal. So here the direction of the force is 30 degrees to the horizontal. Next characteristic, point of application. On the body, the force is exactly acting at a point A. A force can be replaced or represented. A force can be represented by an arrow mark. See, the pointer exactly at where it is touching the body is called the point of application, or the point of application is the point through which the force is being acted upon. So here the point A is point of application. And next characteristic, nature of the force. Here the nature of the force is a push. Here the force is pushing the body. Let us see another example. Yes. Here the same force acting through the same point. Let us see the difference. Here also the magnitude of the force is 10 newtons and the direction of the force is 30 degrees to the horizontal. The point of application is A again, and the nature of force is pull. In the previous case it is push. In the previous case the nature of force is push. Here all the three, direction, point of application and magnitude remain same and the nature is changed. So the work done on the body or the effect on the body changes. Like that, all the four characteristics are very important to define a force completely. Now let us see the system of forces. If a single force is acting on a body, then it is easy to find its effect. The force may tend the body to move in the direction of force. But when number of forces acting on the body, it is difficult to find its effect. If a number of forces acting on a body simultaneously, then it is called system of forces. The body is said to be under the action of system of forces. The system of forces, when two or more forces acting simultaneously on the body, is said to be under system of forces. Now, let us see the classification of system of forces. System of forces is broadly classified into two categories. One is coplanar system of forces and non-coplanar system of forces. Coplanar system of forces again categorized as concurrent forces and non-concurrent forces. Non-coplanar forces are also classified as concurrent forces and non-concurrent forces. These are the basic classification of system of forces. Again, there are derived classification, these derived types of system of forces that we will see in the next slide. Now let us see concurrent and non-concurrent system of forces. The force F1, force F2 and the force F3. All the three forces are passing through the same point and the force F4 is not passing through the same point. If we see only three forces, F1, F2, F3, all the three forces are having a common intersection point. All the forces are passing through the same intersection point, or the forces have a concurrent point. All the forces are meeting at same point. These three forces are called concurrent system of forces. F1, F2, F3 forms concurrent system of forces. Now let us introduce another force F4, which is not passing through the point of concurrence. The force F4 is intersecting with F1 and F2 and not at the same point, at different points. Now, the system of forces including F4 is non-concurrent because in the system of forces there are four forces and all the four forces don't have a common intersection point. So, concurrent force system is defined as the system of forces in which the lines of action of all the forces meeting at the same point are called concurrent force system. Non-concurrent force system is defined as if the lines of action of all the forces in the system of forces not having a common intersection point. This is called non-concurrent system of force. And now, let us see again, F1 is acting on a body from plane ZY to plane XY. And another force F2 is meeting the force at point of concurrence. F3 is also coming and meeting at the same point, but here all the forces are meeting at same point, but they are not in the same plane. In the previous example, all the forces are within XY plane, but here in this example, all the three forces are meeting at one common point, but they are in different planes. Now introduce F4. F4 is intersecting with F1 only. Now all the four forces are combinedly called as a non-concurrent system, because in the system of forces, one force is not meeting at the same intersection point. So the complete system is called as non-concurrent. If you remove F4, then it is called concurrent system of forces. Now let us see another classification from the same example. The first example is coplanar system of forces. In the first example, all the forces are lying in the same plane. So that's why they are called as coplanar system of forces. And the second example, all the forces are not in the same plane. The lines of action of all the forces are not in the same plane. That's why they are called as non-coplanar system of forces. Right. Now let us see some derived cases. Parallel system of forces. Parallel system of forces is a derived case from non-concurrent system of forces. See here, non-concurrent system of forces don't have a common intersection point. It also says that they don't have a common intersection point or not at all meeting at any point. If the force is not meeting at any point, that means they are parallel to one another. See, it is another case. Parallel system of forces is a case of non-concurrent system of forces where the forces don't have a intersection point at all. So here's, for example, two forces are there, they are not meeting at all. Right, now these four forces are called parallel system of forces. Why? Because the lines of action of forces are parallel to one another. In the same example, two forces are in the same direction and other two forces are in this example, two forces are acting in same direction and other two forces are exactly opposite in the direction. The forces which are in the same direction are called like parallel forces. In the parallel system of forces, if the forces are in the parallel system of forces, if the forces are acting in the same direction, they are called like parallel forces. And if in the system of forces, if the direction of forces are not same, then they are called unlike parallel forces. Now next classification, that is collinear system of forces. This is a derived case of concurrent system of forces. In the concurrent system of forces, all the forces will have a common intersection point. See, in the concurrent system of forces, all the forces are having common intersection point and they are in the same line, then they are called collinear system of forces. See the forces 1, 2 and 3. If we extend the line of action of all the three forces, they are lying in the same line. The action of forces or the line of action of forces is same. So that's why these forces are called collinear system of forces. This is the classification of system of forces. In this lecture, we have seen the introduction to engineering mechanics, the definition and characteristics of a force, and the classification of system of forces. Thank you.